Hey, Kyle, how are you doing?
I'm doing great. I'm just chuckling. You had a comment. There isn't anything that I haven't done except for being the founder of Keep Calm and Refactor. That I haven't done yet. So I think
Yes, that's a good one. Really excited to have you, Kyle. Now, the floor is yours.
Thank you so much. I appreciate it. This is going to be kind of a lightning talk style because as I was presenting this to my wife last night, she said, "Kyle, you realize how far over time you are." So I'm going to flip through very, very quickly. Thank you, Beth, for the kind introduction. I'm the founder of Runwen. We're building agentic AI for SREs, platform engineers, DevOps, et cetera, et cetera. But this is a little bit. I pulled some numbers from our own personal dev journey as big users of any and all AI engineering tools that we can find for our own productivity. So I'm kind of going to start there. I pulled. This isn't very scientific, so my apologies if it's if that's kind of what you want. This is a lot of back of the envelope as I look through our own history from a bunch of repos. I just did kind of a quarter-to-quarter comparison and some monthly averages of before we were using as many AI coding tools as we possibly could, and after. Some of this, I think the first stat on the left is old news for a lot of people who are listening to this. We're up a solid 25% by lines of code written per person after experimenting with a whole bunch of different tools and different people in the team settling into a few. So that's pretty awesome. The one in the middle, as both somebody who's contributed about 500,000 lines of code per product and as the CEO, the middle one really makes me very happy. We're up like 30% of story points that we deliver in a sprint. And that's a big deal. To me, that says, I'm watching it. We get through code much faster with less mental energy spent there. So a lot more mental energy gets spent on, are we doing the design properly, and are we really solving the end user's problem before we even jump into a new feature? So that middle one to me is really, really interesting. And I don't think as many people in the industry are talking about that. But the right one is very interesting. And I hope a little, well, let me just leave it. It's interesting. By lines of code that we're actually running in production, we're growing like 55%, growth per month of 55%, because the sheer amount of using a whole series of AI coding tools, the amount of new open source that it's bringing into our environment is massive. And kind of our ability to grow our tech stack is so fast. I'm sure that this will change over time, right? As code bases get very, very, very mature, the tech stack changes a bit less. But this is a fascinating stat, and I'll show you why in just a sec. So here's another stat. We started separating out. We compared like for like PRs, and we started calling them landmines. And we said, hey, when a developer hits a landmine, and we define that as they hit a blocking issue because it's somebody else's code is doing something different from what they expected in our shared environments. Third-party open source is doing something different from what they expected. Third-party SaaS is doing something, infrastructure. This was true before we started using our AI coding tools very heavily, but now it's ridiculously visible. And I have to tell you, like, as the CEO of the company, this is such a huge visible thing, because I just watch our folks, myself included. Hey, here's a sprint where you didn't hit a landmine, and wow, we're flying. And here's a sprint where you did. And hitting a landmine undoes 100% of the productivity benefit that we've gotten from any AI tool ever. I'm just going to read it. If a developer hits a landmine, all productivity gains are lost. So look, this for us is a problem to solve. I don't have as good stats on our own uptime and downtime, but there's kind of the SRE equivalent that we certainly see amongst our customers in a big way. When a single SRE hits a blocking issue that requires somebody calling their colleagues, especially when it requires multiple teams getting involved, the MTTR time jumps up by a huge amount. Again, I don't have good stats, but we can kind of see it and feel it. So I'm assuming that if we actually did pull some customer stats here, you'd be able to see it too. So when we first started thinking about like, hey, this is a problem that we want to solve, there are two interesting paths. One was, what if we took a technique that a couple of us have seen at FANG companies? It's been replicated by a fairly small number of others. And it's almost like, it's automation, but think of it almost like unit tests. Like, let's build a huge number of unit tests across our infrastructure, across all our third-party open source, across our platform, et cetera, and keep on building up from there. It's a huge amount of work to get it up and running. I mean, I saw this on my last team. But once you do have it up and running, it's extraordinarily good signal to noise, and it's got this other really interesting property that the human readable text to generate. Hey, here is a check, and the check failed, and here's why. The human readable text is excellent. Hint about what's going to happen next. The other path that we didn't go down was, hey, let's limit it to going back and forth with observability tools. Look, it's much less work up front, but you're missing a lot of context. And I think anybody who started playing with this area very seriously recognizes that your metrics and logs alone require a lot of other data to get fed into an LLM to get anything useful back out. And a lot of the most interesting thing that's going on actually doesn't really have a whole lot of human readable text. So making this useful for LLMs, it's odd to see that this troubleshooting data that's useful for humans is actually almost completely useless for LLMs. So anyways, in very, very, very early on, we made the design decision while we work with observability tools to mostly focus on building out these automated checks. And our design goal kind of evolved a couple of times over the course of early development, but it's kind of settled in, like, could we build something like cursor.ai? Because we all love that tool, but could we build it for SRE work? Not only for SREs, but for any developer that is like at risk of hitting a landmine. Hey, something is wrong. I don't think it's my code. I think it's something else. Can we avoid a landmine really, really, really early by having a cursor type of thing? Check. Can you run 20 checks? Can you run 30 checks? Can you explain to me what's going on? It's also used in production, right? Obviously, like when an SRE sees something, oh my gosh, I'm seeing something that I haven't seen before, or I'm not really sure what this is, or I'm not really sure even which team this is. Same stuff applies in prod and non-prod. So this was kind of the core project that we worked. What seemed like an interesting glimmer of an idea about 2 years ago, it turns out that to make it work, it needs lots and lots and lots of tools. We built up a library that's now got I don't know how many, probably 700 or 800 now. We add like 10 a month, so it's a lot in the library. And then when we do these automated installs, typically we're talking about 5,000 to 10,000 tools for a dev environment, because that's about the corpus of what a really high-end expert human trying to troubleshoot, infrastructure, platform, OSS, third-party SaaS, all the way up into application logs and metrics. That's kind of about the corpus of skills that you expect in a real expert engineer. So it's fascinating because it's a lot, but it's not infinite. It's just a very, 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 very large number of skills, called a very large number of tools. Now, I think since we're using, agentic AI at this tool scale, there's some really, really, really interesting problems that are emerging for us out on the other side. A really hard problem became, you can't just dump it all into a context window and hope for the best when you're trying to do tool selection. We have to solve something that looks an awful lot more like search. Start selecting out from the corpus, like, hey, here's some interesting tasks to run. But it's a really interesting search problem because, in typical search, you have sort of a couple of keywords in the query and you have a couple of keywords in the result, and they kind of match. Here, the typical queries are describing a problem. Like if you think about the body of an alert or the body of like, hey, I think this is down, most of the words involved describe the problem, and they're not actually, those words actually don't show up in the description of any of the automated tools. So there's this really interesting lexical translation problem. There's also this really interesting location problem that, say I'm trying to troubleshoot cart service, I'm using my old team's sort of canonical learned Kubernetes example of online boutique. I'm trying to troubleshoot cart service as a deployment in Kubernetes, but actually the really interesting tasks are in the online boutique namespace. And I'd never even mentioned the namespace as part of my query. So there's this very interesting translation layer, not only in terms of problem to solution, but there's this really interesting translation layer in between, like, where are you in the infrastructure and like what's nearby? Which microservices you're troubleshooting, which are the dependent ones? Okay, which part of the infrastructure are you in? We used to call it the New York versus London problem, or the dev versus prod problem. You really, really, really want to avoid that high cost, like terrible situations where you're using this cursor tool and suddenly you thought you were troubleshooting something in a dev environment. It's like wandered off into staging, or even worse, wandered off into prod. We came up with what I think is an interesting solution for that, very much inspired by Google Map Search. I mean, it's fascinating. You go into Google Maps, you don't even think about it. You type in like Thai food, and then you get all of these really interesting search results where the word food was not in the title because the web pages say restaurant. It's Thai and related cuisines. And sometimes, very often, nowhere on the web pages they actually even say the word Thai, which I always think is very interesting that they can do that. And second, it winds up not searching for Thai restaurants all over the entire planet, but searching for Thai restaurants that are really relevant to my location. So long way of saying, I know I'm time in this one, but the vector search that we do is not traditional semantic search only. It's semantic search as part of a vector, and then a lot of other information in the vector that turns out to make this search work really, really well. It's a very unique and interesting search domain. Just find that area fascinating. It's actually required to make the agentic AI in this area go well. A fascinating non-problem that we have, because we sort of enumerate all of these tools, all of these tasks, all these capabilities up front, RBAC becomes really, really easy. Some people are allowed to do remediation in dev environments, but not in production. Or some people are allowed to do a lot of information gathering in production, but they have to ask somebody else in the organization to help when it comes to time to change and config. So that turned out to be a set of extraordinarily easy problems to solve that I think a lot of like AI for this other 70% of engineering for these troubleshooting problems has a really, really, really hard time with. And then if I look forward, an unsolved problem, and I can tell you with great certainty, at least on our side, it's unsolved. Like building MCP servers with 10,000 plus tools is really, really, really straining, I think, the intent of the MCP of MCP and A2A. So I think carving up this problem space, we're going to see a lot of really, really interesting best practices emerge over the next 1 to 2 years as MCP servers scale. I mean, we're already there. Not only 10,000 tools, but you add in Jira integration, Confluence integration, that kind of thing. Our tool count gets very, very high in addition to our own 10,000. And I think this is going to be a fascinating area to watch. We're active in it, and my guess is that I'm sure that at least some of the other presenters here are starting to see these early problems show up in their own early product design. That was my lightning talk as fast as I could get it. I know that now at this point, Bap, I think we were back over to Q&A, and I think that or at least I hope that I managed the clock.
Hey, Carl, thank you so much for this very cool presentation. And yeah, it definitely seems like there is a huge opportunity, and I understand why. Yeah, you are building this company. Yeah, just this concept of landmines is definitely a very, very interesting one, and how there's space to really improve. Now, I'm checking quickly and briefly at the community, and I think, a lot of people were resonating with what you were saying. Just quickly calling whether or not anybody has any questions. Of course, as I've mentioned in the past, if any of you want to take this aside, you can always directly contact Kyle, who I'm sure will be very, very happy to have a chat on the side. But I see Macy has an example. Macy just commented. So what's an example of a gnarly landmine? That's a good one.
I mean, I can tell you one that for not one, but two of our developers, given like the expectation of productivity that we've created for ourselves because of all the tooling that we have, one where we didn't have task coverage in our own tool, right? So now like those are like really, really visible on our side. This happened about 6 weeks ago or something like that. It turns out we were using Celery for a series of kind of offline automation, or offline kind of like long running tasks. We were using it as a job runner in one part of our infra, and it was, the root cause was that Celery was effectively running out of memory. It was clearly making a whole bunch of calls that were appropriate in a small dev environment, and in our larger test environments, download gigantic amounts of data. Not super surprising, but the way that it manifested itself, like the fact that it was actually this sort of offline job runner, manifested itself in these really weird ways because it was shared test infrastructure. We were running out of Kubernetes cluster capacity, so a bunch of other things were doing intermittent failures, and the failures were very intermittent because this thing only on some test runs would run itself way out of memory. There were a series of assumptions that we had in a very, very, very early stage part of the code about how long those Celery tasks would take to run, and what happened if users were taking several actions like while they were still running, which was just a design error on our side and very, very early code. But this really, really exposed it. We didn't see the Celery problem. We didn't see the memory problem early on. We just saw these other problems manifest themselves. So it wound up being two of our backend folks, which for us is kind of like, sure, like getting two people working on a problem for like an hour, okay, that's totally normal. But it was two folks working on this for like almost 3 full days because of the really funky areas in our application where this manifested itself. It was both an infrastructure issue as well as an application issue, and it just happened to be in an area that for our library we hadn't tooled up. So I would say this was a gnarly landmine, because at this point for us, losing like 2 full days in a 2-week sprint across 2 people, 2 years ago, like it would have been kind of an issue maybe, but like we're so much more productive now that's a huge loss.
Yeah, ouch, as Messi said properly. Yeah, I think that was a very, very insightful example. On our end, we think this is like probably the perfect segue to jump into the next section. But before doing so, just wanted to say a huge thank you to you, Kyle. Really, really enjoy this session. One last little, at the risk of making myself redundant, but please reach out to Kyle if you have any questions. Yeah, thank you so much for the amazing chat, Kyle.
Bab, thank you so much. We really appreciate the time.